Hey, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench I have a Bryston combo. The Bryston 3B power amplifier and a Bryston 0.5B preamplifier. And they came in as a pair. This is a client unit. He wanted repairs done. It's got two problems that he mentioned. One is the power switch on the preamplifier is buggered up. It said it was latching on and he couldn't get it to latch off. But then when he brought it here, I was playing with it and I just let it snap out, and then it started working again. So maybe that switch needs to be taken apart, cleaned, or maybe even replaced. I don't know. But he did say that it was latched on, he couldn't shut it off. So I think what he's doing is he's switching this heavy load with this switch, and that's a power switch killer if you switch on heavy loads. But I don't know if that's the case. Anyways, the second issue he had with it is he says it's got a hum. Now, he bought this off somebody else, and the previous owner told him it has a hum, and it wasn't that bad. Okay, so he gets it home, he connects it up, tries it out, and yeah, it's got a hum. He says it is quite noticeable, and it is a lot worse than what the previous owner made out to be. So let's dive into that. So let me connect it all up, and then I'll power it up, and we'll hear if you can hear the hum too. I can hear it plain as day when I connect it to my speakers. I listened to this for a few days, and yeah, it's a great sounding setup. I like this amplifier preamp combo. It's very nice. It works flawlessly. Volume control is nice and clean. You got a function switch, input function switch. What else do we have? A tape monitor switch, a balance pot, a mute switch, and that's it. There's no tone controls. A low filter over here, a rumble filter I guess for turntables, but that's all you get for this. Just great sound flowing through. Before we go too far, let's have a look at this power cord going in. There's no external fusing that we can see here. Got an unswitched outlet and a switched outlet, and they're both grounded. Let's see, this is an 18.3 power cord with a ground, so the ground's following through. We have our preamp output, left and right. We have our tape monitor output, tape out to our tape deck, tape monitor input, CD auxiliary input, tuner input, and our phonos way off on the side here with a grounding lug. Yep. All gold plated, very nice. And for the power amp, looks like we have two 1/4-inch phono jack inputs, and then we have our RCA inputs. Now this is an amplifier that we can bridge, so I believe if you connect that to mono, and I think you have to separate that. I'm not sure, I have to read up on the owner's manual, but we got two RCA inputs for stereo, two outputs, no switching for the speakers, no switching for anything else. Two fuses, and for the 3B, let's see here, this should be a MTH4. What do we have? Four amp. That's a 4 amp. And this one here is a 4 amp as well. So it looks like they're doing monoblock design with two fuses here. I don't know what they're doing. I have to open it up and look inside. I've never seen one of these before. But everything seems correct. Alright, connected to a pair of speakers. I'm just looking at this power cord. It looks like medical grade. It's got a green dot on it. Oh, it is medical grade. It says hospital grade right here in the bottom. This is the original power cord. I wonder what makes this better than just regular. I don't know anything about hospital grade electronics, but interesting. Anyways, so you got them both plugged in here, consuming zero current, zero power, with them shut off. Turn on the preamp, a little relay click, It's going to settle down around 10 watts, which is fine. Power amplifier jumped up quite a bit. It's going to settle down 40 watts and climbing. So when I was using this, it's idles, both units on, it idles about 60, 70 watts, somewhere around there. You can see the bias is coming up slowly. So anyways, I have right now speakers connected, and the power amp's turned on. I don't hear a thing. Silent. Now I'm going to turn on the preamp. I have nothing connected to the inputs. I'm on CD auxiliary. I don't know if you can hear a hum now. It's a lot quieter than when I can definitely hear hum in the preamplifier. I wonder if I can get it so that you can hear it too. Yeah. It's already shot up to 80 watts. Why is it still climbing? It never went that high before. And my mistake, there is level controls here, hidden in the front. There's two little trim pots that you can adjust. I do believe these are level controls. They wouldn't be bias, that's for sure. It's not as dramatic as when I was trying it on my listening bench. I could hear it quite distinctly, but now it's very muted, the hum. Yeah, now it's starting to climb back down again. It went up to peaked at 80, and now it's coming back down. You see the wattage coming down. So I guess it's just a preheat thing that it has. Slowly climbs up and then slowly climbs down again. Okay, I'm just going to try this again. Turning it on. Okay, well that's my body. How come it does it only on the volume pot? Yeah, so that's hum induced by my body into the volume pot. It's not the balance pot and the volume pot. The function switch doesn't do that. That's odd. Let's try phono. And that's preamplifier hum pickup. It's interesting. They must have these insulated from the rest of the chassis. Now I don't know if you heard any of that because it was hum is not that prominent. Oh, hang on. We might have a broken connection inside. Maybe a ground connection. Usually when I hear people talk about hum in equipment, I think right away about open grounds. Either a bad cable where you have a incomplete ground connection. Connectors at the back, they break and they go open, and then you lose your ground connection. Cracked solders inside, you lose your ground connection. Any place where you lose a ground connection, you can introduce hum. Usually it's just a matter of going in and fixing those breaks. That's typically what causes hum in equipment. but there's other causes as well. And I'm just trying to determine if something here is to do with something inside broken. Let's have a look inside. Now I don't know if you're going to be able to hear this, but I'm going to turn this on, and when the relay clicks you should hear the hum come in. I think you can hear that, I'm not sure. But look what I just noticed. I lifted about 6 inches away, the hum disappears. So what we're doing is we're actually picking up hum from the power transformer in the power amplifier. And it wouldn't surprise me if people in the past have just stacked these components and used them, and then the hum is there and they don't know why. They probably change cables around or do different things and they can't figure it out. But all they have to do is provide a little distance between the two units and the hum disappears completely. And I don't hear anything now. Let's see here. That's full volume. Yeah, it's silent after I go about 4 or 5 inches up. Alright, so I think we know the cause of our hum. I got an idea. I'll be right back. So I had a little idea what to do about this. So what I'm going to do, take this off for now. Temporary. And I'm just going to cover this just to protect it. And I went out to the garage and I found something. Got a 1/4 inch plate steel here. Just going to dump it on top. And then we're going to try this again. Okay, so we have 1/4 inch plate between our amplifiers. Let's move this so we can see what we're doing. Let's turn on the power amp. And the power amp doesn't have any relays. It just instantly comes on, which I find kind of odd. So let's turn this preamp on and see if we still have our hum. No, it's silent. The hum's gone. So, 1/4 inch plate steel. What it's doing is it's actually shunting the magnetic field that's coming out of the power amplifier. It's acting like a shunt, and whatever magnetic field comes up from the amplifier is hitting the plate and flowing through the plate and back down again to the transformer. It's not reaching the preamplifier anymore. So in theory you should be able to silence the hum by putting a metal plate between the two of them. The reason this works is because this is steel, it's magnetic, and it's going to actually flow any magnetic flux through it. And that actually works pretty well. I don't hear anything now. I'll try that again. Yeah, I don't hear anything. It's gone. Still have this though. I have to figure out if this is a fault. This could be a broken ground connection. So let's do something about that. Just removing these funny square head screws. See how they got a square? That's a Canadian thing. So I'm just removing the lid. And part of the reason why this is we're getting the hum is because they put aluminum lid on this, and aluminum is not a magnetic shield. It might be good for electromagnetic interference, but it's not good for stopping any kind of magnetics. It just goes right through aluminum. Let's have a look in here. So my client did a little bit of research on this hum problem for this amplifier, and he said all roads pointed to having a recap done. And I disagree with him here on this one. I don't know what year this thing was made. I'm guessing mid to late 80s. But I don't think the caps have failed. Not to the point where a recap is necessary. So we have, this is a monoblock design, I'm not sure. I think it is. We have rectifiers for got two transformers, two sets of rectifiers, two sets of capacitors. And it looks like the power wires don't intermingle with each side. So I think it's a true monoblock design. We can test capacitors, but I don't think it's necessary to change any at this point. Yeah, everything looks good in here. I don't know if you can see inside very well. Looks like we have some kind of input board here in the back. And some loose screws and stuff. This is loose. I might do some work on this just to make sure we don't have cracked solders. And I'll check capacitors as well. Yeah, very nice. That's why it's so heavy. It's got two big, massive transformers in it. This thing weighs a ton. Okay, I tested all these caps. These ones, there's one up there. They're all fine. I'm not going to touch any caps on this thing. Just going to make sure everything's secure, everything's tight, which it should be. This here I'm going to fix. This has got loose screws here and here. I'll tighten this all up. And then I'm going to put this aside because there's really nothing more I can do with it. I'll probably test the bias on it too while I'm here. I think I'll do that. But I'm just more concerned about the loose screws. You get a screw fallout and then it's rolling around inside and then it makes a short circuit and everything goes kaboom. So we want to try and avoid. So I'll fix that up and then I'll look for instructions on setting bias. Don't know what the values are. There is points here for taking measurements, bias measurements, so I can do that. So as far as biasing goes, I can't find a value on the webs. I did some searching, but I did check this side. This side was about 18, 19 millivolts. I checked this side; it was up over 40, 45. So I turned this side down. And now we're at about 17. I'm just going to go back to the first side and we'll see what we got here again. I happen to think the one side was too high. I really didn't notice one side getting hotter than the other. Yeah, this side's at 17 as well. I'm going to leave that alone. They're both the same. Our overall consumption is just under 60 watts, which is nice for an amplifier of this caliber. It's got dual transformers, so 60 watts idling is pretty much normal, I'd say. So yeah, I'm going to leave this alone. So I'm going to close this up and put it aside, and let's look at the preamp. Alright, got the screws out. I think I have them all out. Yes, we do. Oh, look at this thing. Nice. Very nice. Still don't know a date. Oh, here's a date. So this is March 24th, 1989. So 89 build. That's good. Good to know. And I don't expect I'll find anything wrong with these. What I do want to do is remove this main board and check this switch. It's kind of moving around when I push it in and out. Oh, you can't see it. Might have cracked solder joint. I'm mainly concerned about cracked solder joints. So let me see what we can do here. I have to take the bottom off, I think. How does this work? 2 screws takes the front panel off, and everything is screwed from the bottom up. And it's one big board. So it can all come out. I'll take the front off, and then I'll just remove the board from the bottom plate. Alright, removed all the screws. Oh, there we go. There's the bottom plate. Let's have a look at some of this. I don't see any cracks anywhere. Don't see any cracks, but what I'm going to do is I'm going to clean this well to get rid of some of this flux. There's flux everywhere. And then I can give it a good inspect with the lens. I think everything is okay here. Yeah, it looks very nice. Very nice construction. They weren't fooling around when they built this. But I do see a problem. Maybe not. No. Everything's looking good. Okay, going through looking at caps here. It looks like I'm going to need to do some recapping. I tested these blue ones, these blue axial caps. There's 6 of them here. These are 220 at 6 at these are 220 at 16 volt, no, 10 volts. And I think one measured 220, the other ones are measuring 160, 160. There's some that measure 80. So all the caps are degraded. These orange ones I haven't tested yet. We could do that right now. Let's see here. What was it supposed to be? It's supposed to be a 10 microfarad, 40 volts. Okay, so let's positive there. This one here is a 447 at 50 volts. It's measuring 22, which is half of its value. And this is supposed to be a 10. Let's see what this measures. Just out of curiosity. 9.5. Okay, well, it's not bad. Let me see another one here. 9.4. 9.3. 9.3. So maybe these orange ones are okay. These blue ones are definitely not okay. And there's 3 blue ones here that are bad. So I'll go through, and if the orange caps are okay, I'll just leave them alone. They're Siemens caps. These ones are Philips. And these blue ones, I don't know what they are. Doesn't really say. Alright. So I'll finish this up, and then that'll be it. Alright. So I replaced all these caps. These caps are all dead. Every one of them. I think except for one maybe, but whatever. And I tested all these orange Siemens caps. They're all fine. They're actually really well. Good condition right now. They all measure up. So having troubles finding schematics for this one. I pull up the 0.5B preamp schematics, and they all have op amps in them. This is all discrete. So I don't know. I don't have a schematic. It's kind of confusing searching for Bryston schematics. They all come packaged together. Now I don't know what to do about this power switch. It's working fine. I think it might have had a mechanical sticking. All I can do really is just lubricate it. Let's just give it a shot of lubrication and hope that's the end of it. Flipped it over, checked all the solder joints, no bad joints on any of the connections. So everything's looking good. Ready to put this thing back together. Okay, so I talked with the owner and I talked to him about this power switch. I asked him what was the problem with it, and he told me that it was stuck in the on position. Now, it's working perfectly fine now. It's not stuck in the on position, but I have a feeling the contacts were welded. Probably from switching on heavy load. If he's got the power amp plugged into the back of this thing and he's using the one switch to turn on both units, good chance that the contacts welded themselves together, but now they're broken free. I really don't like taking these switches apart because there's you know, they're plastic molded case, and then they use some ultrasonic welding, I think, to close them. And well, actually it's 4 posts, and I think there's 2 posts here and 2 on the back, maybe, I don't know. And what they do is they use some kind of plastic fusing method to close the case up. Once you open it up, you kind of break that, and you can't really get it to it's not good to. So this one's rated at 4 amp at 250 volts. You probably can't read. I'm going to see if I'll zoom in if you can read what I'm looking at. Probably not. Okay, get a little pointy device here. It says right here 4 amps, 250 volts. And it also says something else. If you can read this here. If I get some reflection on it, maybe you can read it. It says shadow, SCHADOW, and it says type NE15. So this is the part number of the switch, is NE15, November Echo 15. I did a search for NE15 switch, and it comes back nothing, both on DigiKey, and I did AliExpress and all that. But this is a kind of common footprint for a switch, and if you search for NE18, you'll get lots of hits. Okay, and I happen to suspect that the NE15 and the NE18 are pretty similar in physical size and configuration. They have the pins, PC pins sticking out the bottom, and it's got the latching mechanism, and some of them have the solder lugs at the top. So I think it's just going to be a drop-in replacement. I haven't checked the dimensions yet, so don't quote me on that. You go in and you measure all the dimensions of the switch, make sure they're the same. But even if it's not the same, we have some play here. We can, if the switch is larger, we can install it, and it can still, before it hits the transformer. And if the holes don't line up, we can drill new holes in the printed circuit board just to make it fit, and that's not a problem. One thing I don't like is how that switch moves when I latch it. The switch is kind of rocking back and forth there. That's not cool because these pins can break after so many cycles. It's not really a great design. So I'm going to get an NE18. I do actually have some NE18s in stock that I purchased. These are more for the NAD. So this is an NE18. And if you can read it on the top there, it says it's right here. It says NE18. You can see that. But this one has the double pull, double throw switch installed. This is for, I bought these for the NAD, the NAD receivers and amps. They have these switches in there. And I bought these as replacements. And this one here is rated at 5 amp. I think it says 5 amp or 6 amp, something like that. So this would be a good, but obviously it's too long, right? Because it's got this body here. So I need to get this switch without this nonsense in the middle, and I think it should be a drop-in replacement. And I see some on AliExpress, I see some on DigiKey, but DigiKey is being really weird right now. I can't actually put anything in my cart. It won't let me. I sent an email to their tech support, no answer. So I'm gonna look and get. I'm gonna order in some NE18s from AliExpress. They should be drop-in replacements, and then we'll get the switch replaced. All right, so it's a couple weeks later. The switch has arrived. Let's see what we got. Now, I just want to mention this in the video. I tried ordering and buying a switch off of DigiKey, one that would fit and be proper, but their website was down, and I couldn't order anything. I couldn't add anything to my cart. So what I did is I went to the technical support page, wrote a little email saying, hey, you guys, heads up, your website's not working. I can't seem to get an order in. Blah, blah, blah. Thanks. Talk to you later. 3 days later, they responded, oh yeah, our website's down. We're working on it. That's all they said. Another week later, I went back and checked. Still couldn't order. Website was down. So come on, DigiKey. So here's what I got. And it looks pretty darn close, to tell you the truth. It looks pretty good. Let's get this out of the bag. Yeah, this came from AliExpress. And I paid dearly for it too. Now it's new old stock. It's got all the safety certifications on there. CSA, Underwriters, Laboratories, all that. So that's good. Made in Germany. It's a legit switch. It's got a good action. Now, is it the same physical size? I don't know. It does look like it is. Looks like it's drop-in compatible. Okay, so let me get this board out and see if we can get that switch out of there. All right, so let's get this going. They folded over the pins to make my life more difficult. I guess it's to hold it in better, but I don't know if that really works. What I'm going to do is I'm going to secure the new switch down with some adhesive to the board so it won't move. This one, when you press the button, it moves. The switch moves all over the place. I'm surprised that these pins haven't cracked or broken. Where is my screwdriver? Okay, so I need to flip these up without damaging the board. Okay, there's one. Two, and two over here. Okay. Switch is loose, just about. Clean this up a bit. Okay. All right. So what do we got here? Looks pretty good, I think. Looks almost identical. Oh, that's tight. Is it glued on? There we go. Oh, that was tight. So our pins line up perfectly. We have this problem here. This is not going to allow it to sit flush on the board. See this part? I have to cut this off. Cut this off. It looks like it's for snapping into a Get rid of this, get rid of that. And let's cut this off. There. Now it should sit flat on the board. Almost. Trim these too. There. Just flat on the board. Everything else is dimensionally the same. Okay, so what I want to do is I want to apply some adhesive here before I stick it to the board. First, let's clean this up. Let's clean this mess up. Okay. All right. So we got our cap. Okay. Now I'm going to put a little adhesive right here on the belly of the beast. Right there. And that should be enough. All right. Make sure this is seated. Okay. All right, we're done. More alcohol. Okay. Alright, ready to reinstall that board and we're done. Once this adhesive sets up, that switch is bonded to the board, but it's pretty solid now. It's not even moving. Well, it's barely moving, not like the other one was. The other one was rocking back and forth quite a bit. Pretty good. Alright, back together again. Reassembled, everything went well. Took the board and cleaned it after I replaced these caps. These are all Phillips caps, by the way. These ones here are actually Phillips as well. Phillips branded, 220 microfarad, 10 volts, and they measured a few of these measured around 95 microfarad, some around 160, and then there was actually one that still measured up around 220, but they all went. These are Phillips branded as well. These are 47 at 50 volts. And they all measure down around 22 microfarad or somewhere around that area. So add Phillips to your list of caps that need to go, because Phillips from the 80s are not holding up. Alright, so that's it for this one. So this can go back to the owner along with the power amplifier.